the displacement of the point of the wheel initially in contact with the ground when the wheel rolls forward half a revolution will be given radius of the wheel is r. So, as per this problem, there is a wheel which rolls in forward direction. So, if we consider that wheel, let us consider here floor first, okay. Ground we can consider, let it be ground, okay, ground, and in this ground there is a wheel. Let us consider this as a wheel, okay, like this I will consider. So, now this particular point, if we consider this particular point, that point is in contact with the ground, okay. Now, let us consider that as A, point A is in contact with the ground, and I will consider the diametrically opposite point somewhere here, let it be B, okay, and given that the radius of this wheel, okay, this is actually wheel, okay, this is wheel, and given that radius of this wheel, that is equal to how much? R. That means here to here this radius will be R, again here to here R. So, we can consider the diameter or the distance AB, that is known as the diameter of this wheel, okay. So, if radius is R, diameter will be 2R. So, let us consider this distance AB as 2R. Now, the question is, since this wheel is rotating in forward direction, it rotates like this, okay. So, as it rotates, what happens? After a certain time, that wheel will travel certain horizontal distance, okay. So, the question is, after half the revolution in forward direction, after half the revolution in forward direction, then what is the displacement of the point which is initially in contact with the ground? That means, after half revolution, what is the displacement of this point A? That is the question. Got it? So, after half revolution, how much displacement is taken by this point A? So, what happens if it rolls in forward direction? If it completes one rotation or if it completes one revolution means if it rotates in clockwise direction, what happens? This A must move like this, and finally after covering the certain distance, what happens? Again that A will be in contact with the ground. That is when complete revolution is taken. But as per this problem, you need to consider only half revolution, okay, half revolution. So, for complete revolution, the distance travelled, if we consider distance travelled as d, that will be equal to 2 pi r. Why? Distance travelled will be equal to circumference of the circle or circumference of this wheel. But here you need to consider half revolution. Half revolution means the distance by 2 you need to consider. That means 2 pi r by 2. That means what you get? The distance will be pi r. The horizontal distance covered will be equal to pi r. Okay. Anyhow, after half revolution, where will be this point A? After half revolution, if we consider, of course, it moves in forward direction. So, after a certain time, let us consider that wheel reaches this particular distance, okay, and this is the horizontal distance from here to here, the horizontal distance covered, that is what we got it now, that is pi r. So, this distance we know now, that is pi r, horizontal distance covered in half revolution is pi r. If it completes one revolution, then this distance will be equal to 2 pi r. But in this problem, you need to consider half revolution. So, in half revolution, this wheel covers a distance pi r in horizontal direction. So, now at the end of this half revolution, where will be this point A? Initially, that point A is in contact with the ground, but after half revolution, what happens? This A goes like this and that will reach this particular point. That means it rotates, and finally after half revolution, the point A, that point A will appear at this particular point. Then what about point B? Yes, that moves down like this, correct, no? And that is finally at this particular point. So this will be B. I hope you got it. So after half revolution, the point A, which is at the bottom of the wheel, that will appear at the top of the wheel, and the point B, which is at the top of the wheel initially, that will appear at bottom of the wheel. So now what is the question? What is the displacement of point A? What is the displacement of point A? So what is the displacement? You know, displacement is nothing but straight line distance between initial and final position. So this is the initial position and this will be the final position. So for simplicity, I will consider this point as A dash and this point as B dash. New positions of A and B, I will consider that as A dash and B dash. Now we need to calculate displacement of the point A. That means this particular distance that is needed to, that is what we need to calculate. Now what about this distance? Okay, what about this particular distance? This is nothing but diameter only. That is same as that of this. That means this is equal to 2r. Okay, so now what do you need to calculate? We need to calculate A dash. So that is the displacement. So what is the value of A dash? So how to calculate A dash? This looks like a right angle triangle, no? Okay, this looks like a right angle triangle. So you can apply Pythagoras theorem. So as per that theorem, A dash, that is equal to what? Or A dash square equal to AB dash square. This is nothing but B dash. Okay, AB dash square plus A dash B dash square. Or we can write A dash square equal to square root of, what is that? A B dash whole square plus opposites, that one is A dash B dash whole square. Now what you need to do? Just substitute the values. What is A dash? Sorry, AB dash. AB dash is nothing but pi r. So pi r whole square plus what is A dash B dash? A dash B dash, that is 2r, that one whole square. So now you can simplify it, no? So what do you get? That is equal to root of pi square r square plus 4r square. So what is common now? Here you have r square, here you have r square. So take that r square outside. So if you take r square outside from square root, that becomes r. So r into root of pi square plus 4, that is A dash. So A dash is nothing but displacement of point A. Initially that point is considered as A, or you can just consider that is the displacement of the point which is initially in contact with the ground. So r into root of pi square plus 4. So if you look at the option, which is that option? Yes, that is second option, correct, no? R into root of pi square plus 4. Okay.